Screen is visible. So what is your name? Mannan or Bhagirath? 23 BCE 11491. Okay, am I audible? We were discussing about asymptotic notations. So if you take the standard notations and common functions, so it is represented in terms of exponential representations for all n, a greater than or equal to 1. The function a power n is the exponential function with the base a and is monotonically increasing. The efficiency in terms of space and time complexity increases with respect to the number of inputs and based on the logic what we are using. Say for example, the textbook adopts the following conversion. So if you are using binary logarithm, so the time will be log 2n. If you are using natural logarithm or if you are using the exponential on composition or precedence, LG, so accordingly the representation differs as well as the efficiency also differs. So as we discussed asymptotic notation and their efficiency, we cannot say this particular method is more efficient than another method. The method, say for example, if you take the searching, we have linear search, binary search, cell shows, quick search, selection search, and keep search, all those things. So each method performs well depending upon the number of inputs and based on the processor what we are using and based on the lines of code, the efficient code, the statements what we are using. We are using unnecessary go to statements, labels, break statements, continue statements, functions. It will definitely increase the running runtime. If you are using pointers or if you are using dynamic memory allocation and call by reference, or if you are using objects or say the preprocessor predefined macros, then the overall efficiency will increase. So with respect to asymptotic analysis, studies how the values of functions compare as their arguments grow without bounds. And based on the studies and other so many evaluating parameters, so the efficiency increases or decreases depends on the various constraints and bounds. So ignores constants and behavior of the function for small arguments. If your input is very less, in that case, all functions will perform well. Acceptable because all algorithms are fast for small inputs and growth of runtime is more important than constant factors. Ignoring the usually unimportant details, we obtain a representation that describes the growth of a function. As its argument grows and thus allows us to make comparisons between algorithms in terms of their efficiency. So far we discussed what is algorithm, introduction to algorithm, different types of algorithm. Then we discussed algorithm design. Then we discussed complexity, and we discussed asymptotic notation. Already we started with what is data, data structure, and different types of data structures, and introduction part. Then we discussed a classification of data structure also. So the screen is visible. Bhagirath, the screen is visible.
Yes, ma'am, it's visible.
Okay. So if you this particular slide, can anyone explain what is this? What idea you are getting by seeing this slide? So it gives you the overall picture. So for the data structures and algorithms, you should know the fundamentals. Then you should know what are the various data structures available with respect to the programming language. So based on the programming language, if you are using structured programming language like C, the data structures will be different. Some advanced data structures will not be available. If you are using object-oriented languages like C++, Java, and Python, you have advanced data structures and so many macros and built-in functions, library functions. Then you need to understand the various algorithms available. Then within the algorithms, there are some sorting and searching techniques available that you should remember. And while performing the sorting and searching itself, we can perform the same process using recursive functions or non-recursive functions. So within the recursion, we should know what is recursion and what is recursion and recursive function. Then what are all the algorithms available for recursive functions? And if you take the advanced data structures, so the concepts like hashing means we will be using the hash tables. So in compilers, we are using hash tables and heap structures and hash maps and hash sets. They are some advanced concepts. And if you are using the tree structures and graph structures, we have the binary trees and graph representations. So within that, we have a number of types. And if you take the problem solving techniques, there are so many algorithms available and projects. And if you take the portfolio, by using all those concepts, you should be in a position to build real world projects, and you have to showcase the whatever the concepts you studied in the subject, that you should be in a position to implement in the real world projects. So these topics we discussed in the first and second class itself. So what is data? What is data structure? And what is data is the input. Data structure is organizing the data in a form, and algorithms are the step-by-step procedures that accepts the input called data structure and it produces the output. Data structure, data and data structure is the input. Algorithm is the process or function. The function accepts the input and produces the output. We have different data structures and different algorithms. So these slides we discussed in the previous class also. So we discussed these things. What is what? Tejas, Tejas Gupta.
Yes, ma'am.
So any doubt with respect to these concepts? Data, data structure, classification of data structures, primitive, dot, not, non-primitive. So in the previous class, we were talking about data, data structure, primitive data structure, non-primitive data structure. Primitive data structure means the basic or inbuilt or primary data structure, datas or data structures, integer, character, float, and pointers. And non-primitive means it is user-defined data structure. Primitive means unit values or independent single entity, not composite data. Single data is called primitive. Composite data like date of birth, or if you take date of birth will have subcomponents, date, month, and year. The same way, if you take the registration number also, first two digits represents your year 2020 or 2021, 2022 or 2023 in your registration number. Then you have three digits BCE, or we have MIM, BCG, CYB, so that represents the department. Then you have the four-digit serial number based on your admission. So it is also your registration number is also composite data. So we can subcategorize the same way if you take your subject code CSE, or we will say CDS. So CDS means computer science and data science. CCY means cyber security subject. The subject may be belongs to cyber security department, program elective or core elective. CSE means core computer science subject, or if it is MAM, mathematical subject, and MGT, management subject. Some skill enhancements courses, say biology for engineers, engineering constitution, some subjects, social science subjects. So like that, we will categorize the subject code, student registration numbers are combination of different values. So that is called composite or non-primitive. The same way in arrays, we are combining uh, list of integers called integer array. Within the arrays we have, it may be single dimension, two dimension, or multi-dimension. In list itself we have linear as well as non-linear. Linear means a sequence of elements. It may be stack queue or linked list. Continuous memory location will be there. Indexing will start from 0 to n. And a non-linear means discrete values, but all the values are interrelated with each other. Maybe in maybe logically interrelated, or hierarchical relationship, or some parents child relationship. Say for example, if you take what is primitive data structure, there are basic data structures and directly operated upon the machine instructions. So the primitive data structures like integer, character, float, and double are inbuilt data structures. They are part of the compiler. So the compiler understands directly. Integer means it knows what is integer. String means it knows it is an alphanumeric. Data structures that are directly operated upon the machine level instructions or mnemonics are known as primitive data structures. Say for example, integer, floating point number, character constants, string constants, pointers, etc. fall in this category. The most commonly used operation on data structures are broadly categorized into following types. So first we need to create, select, update, and destroy or delete. So while using any data, first we need to initialize. So based on the initialization, the variable is created. Then we need to select the variable name or label. Then assign some value, update the value. Once you come out from the program, the data will be destroyed or deleted. The memory content, the memory is reused for future programming if you are not using files. So non-primitive data structures means the data structures that are derived from the primitive data structures. So we are creating the user-defined data structures by making use of the basic data types called non-primitive data structure. The non-primitive data structures emphasize on structuring a group of homogeneous or same type of or heterogeneous different types of data items. So in non-primitive user-defined data structures, it may be homogeneous. Homogeneous means it may be arrays, all the elements in an array will be of same type. If it is heterogeneous means different types of elements. It may be structure, union. So that is called heterogeneous. So linear data structure and non-linear data structure. Linear means arrays. Non-linear means trees, stacks, all those things. So here we were discussing the arrays, homogeneous, list, heterogeneous. So linear means homogeneous, continuous memory allocation. Non-linear means heterogeneous. So because anyhow they will be having the predecessor and successor values, it can be stored anywhere. So if you take more definition about what is linear and data structure, a data structure in which data elements are organized sequentially or linearly, where each element is attached to its previous or next element, it is called linear data structure. So you know index of A of 0, A of 1, A of 2. So it represents the first element, second element, third element in the array. So within the linear data structure, we have static data structure. Static data structure as a fixed memory size. So if you say A of 10, you are creating an array of 10 elements. So 10 continuous memory location will be assigned for the static data structure. If it is dynamic, in this the size is not fixed. So if it is varying size array, or if you allocating the memory using pointers, dynamic memory allocation. So if you use a new, you are creating a list, you are creating new or new and delete operator, the memory will be, the object will be initialized from the base class dynamically, and that is used for the processing new and delete. Or if you are using varying size array, non-linear data structure where data elements are not placed sequentially or linearly are called non-linear data structure. So any doubt in the classification of data structures, linear, non-linear, primitive, non-primitive, what is what? So anyhow, all those concepts, single dimensional, two dimensional, multi-dimensional, we will be studying in the remaining topics. The same way we will be studying what is stack, queue, creating a stack, adding elements, push, pop, and as well as queue operations, front, rear, queue is empty, queue is full, and the linked list, singly linked list, doubly linked list, circularly linked list, trees, binary trees, AVL trees, A plus trees, the balanced trees, graphs, weighted graphs, directed graphs, undirected graphs, colored graphs, breadth first search, depth first search. All those things we'll be studying in the remaining topics. So already we discussed one lab program, linear search and aim and the logic. Example, pseudocode, the program for linear search using non-recursive function. Here we are using a function called linear search. The function is called in the main program. The function is declared outside the main program and defined outside the main program. The arguments are passed from main program to the function. The function is returning the value back to the main program. So it is non-recursive. Then it is recursive function, the same linear search. The function is declared above the main program. Within the function, we are calling the recursive linear search function. The main program starts here, ends here. The function is called with the arguments. And these arguments, formal arguments are substituted to the actual arguments. And the function is performing the task, the definition of the function outside the main program. It is doing the task and it is returning the result back to the main program, and its return type is integer. The PO is position variable, accepts the input, accepts the return value. And this function is recursive function. Why? Because the function name is recursive linear search. Within the function, opening and closing of the function, we are calling the same function. So it is the function calls itself. And the function, how many times the function will be called means we are calling the function from the main program for n numbers, and we are doing the program for n numbers. Within the function, we are calling the function for n minus 1 time. Again, it will be called for n minus 2, n minus 3, n minus 4 until n becomes 0. So say if you are giving 10 numbers, the function calls itself 10 times. So it is called recursive function. So we can do any program. It is only linear search. We are doing the linear search program without using recursive function, non-recursive function, using recursive function. So any doubt so far? Any doubt so far? Okay, how many of you completed the first lab program, linear search? So when the class starts in physical mode on July 1st. Everyone must come with the laptop with a folder called Data Structures and Algorithms. That folder must contain syllabus, textbook, and the notes what I gave, the basic interview questions and fundamental concepts. I think one more material also I uploaded, handwritten notes. So I will check whether you downloaded all those things and when you downloaded. Whether you downloaded the files on the day when I uploaded. I uploaded all those things on 14/15. When you created the folder and when you downloaded and how many times you refer. And you must come with the laptop. Every day you must come with the laptop along with the observation. So the way you are writing, maintaining the observation, the daily you are completing the task, not daily, whatever weekly assessments we are giving. So when the theory concepts are taught in the class, the same day or the next day you have to execute the program, then only you will understand. We'll discuss today linear search and binary search or merge sort. Again, the next day we will talk about bubble sort, insertion sort. Then if you understood already what is linear search and bubble sort and merge sort, then only when you study the next two subjects, you can compare and understand. Otherwise, all confusing. And one more thing, every class is 1.5 hours. Within 1.5 hours, we're supposed to complete lot of portion. Okay, once again, I will discuss another topic. Already we discussed in lab also. We were talking about linear search and binary search. Already we saw what is linear search using recursive function or non-recursive function. Bhagirath, what we are seeing in the screen? 23 BCE 11491. Priyanshu,
Yes, ma'am.
what we are seeing in the screen? Screen is visible or not?
Yes, ma'am.
Yes, ma'am. It's visible.
Which topic you are seeing?
Ma'am, is the difference between linear search and binary search?
Okay. So anybody can explain based on the diagram how linear search is different from binary search? There is no much logic. There is no much. It's not a big concept. It's very simple concept. We discussed the same concept with respect to library. How we are searching the book in the library. The same way how we are searching a picture or some file. What you downloaded 1 year before or 6 months before. So we were searching so many documents, so many times in the folders or in the mobile. Every day we are searching something. You may be using linear search or binary search, or you may be using hash search. So based on the diagram, so they taken 6 numbers, the same 6 numbers, but the logic differ. If you are searching for a number in linear search, the logic is different. If you are searching the same number, say for example here we are searching the numbers 7. How you search the number 7? Can anybody explain based on the diagram? I think you people are in third year, huh? Second year. You already completed 3 semesters. Anyone?
Ma'am, linear search will check each elements.
Hmm. How you are searching based on the diagram you explain. So we are in linear search, you know very well, you have to search one by one. So your first number is 10. Say for example, your searching element is 5. So we'll compare the searching element with the first number. If it is not matching, now we are going to search for the number 5. Then the search element is 5 is compared with first number, second number, then third number. When it is compared with the third number, the number is found. So in linear search, one by one we searched. In case of binary search, how we are doing? Mrudul,
Like a middle term.
how we are searching? Louder. I cannot able to hear properly.
Ma'am, by checking the middle term of the series.
Binary means divide by 2. So we need to find out the middle element. Even binary search or binary sort, we have to find out the mid value. If you find the mid value, then only the given list is divided into 2 of first of and second of. Then we'll compare the number with the searching element. So in this case, the searching element and the mid element is almost same. And if the element, if the numbers are already in sorted form, then it is the best case. You can easily find out. If it is in unsorted form, then we need to sort, then search. Otherwise, we have to repeat the process until we get the result. For your understanding purpose, I added all those things. So always, can anybody explain what is this diagram? So anyhow, we are comparing linear search and binary search. The binary search runtime is mentioned in green color. Linear search runtime is mentioned in yellow color. So the x-axis represents the number of inputs, and that is n value, number of elements in the array. And the y-axis represents how much time, seconds, how much time we need to complete the task. So x-axis is number of inputs, array number of array elements, and y-axis is the time required to complete the task. So by seeing the diagram itself, you can easily understand which method is best, which method is giving uh, having less time complexity and space complexity. Any data science student in the class? DS 23, BDS, data science, data analytics. Tell me what is from this diagram, what you understood, which method is best by comparing both the methods.
Binary search.
Binary search is best. Even the input number of input increases also. So say when the number of inputs is up to 4 or 5. So when the input is 1, its time and space complexity is very less. And when the number of inputs increases up to 4 and 5, it's increasing exponentially. After 5, it is almost to the same time. So it is fixed with the time complexity of only 3. Even if you give 5 inputs, it takes 3 minutes or 3 seconds to complete. Or even if you give 9 inputs, n equal to 9, it occupies takes the same 3 minutes or 3 seconds. Even if you give 15 also, it takes the same, almost same 3 seconds. But if you take the linear search algorithm, when the input is up to 4, it takes only 3 minutes. When the input increases to 5, it takes 4 minutes. When the input increases to 6, it takes 5 minutes. When the input increases to 10, it takes almost 9 minutes. So it is an exponential growth. So when the input increases, the number of input increases, it needs more time. I think you might have got the idea which method is more efficient one. So we have to evaluate, or we have to compare the algorithms, different types of algorithms used for the same searching or sorting or finding the shortest path based on the number of inputs and how much time it takes, and whether it is an exponential growth or it maintains a default, or what is that we used to say, the threshold value. So the threshold value is 3 or 3.5. It is fixed. After 5 inputs, even if you give 50 inputs also, it may take the same 3 minutes or 4 minutes. So got the idea? I think the meeting will go for another 10 minutes. So any doubt in this diagram? The message is visible to you. Your meeting will end in 10 minutes. So you can take one more for your understanding purpose. I shown you. I taken one more graph also. The graph is visible to you. So here they're taking the array length, the same number of elements, the number of inputs what we are giving to the algorithm. And in the y-axis we are taking time per search. So we are using the searching different searching algorithms. So one is binary search with standard binary search. So that is represented using black color, and one more advanced binary search using uh, simple advanced binary search. It is mentioned in black color with the x notation, and they are taking other modified versions of binary search with the branchless, and binary search with the branchless UR, when the UR is size is fixed, and they are taking the other algorithms like linear X search SSE method, linear search SSE method, linear search SSE with some parameter, linear search with the AVX variable, linear search with the AVX UR variable. So they are all the different methods. So they are taking 5 linear search methods and they are comparing 4 binary search methods. So what we are studying, like binary search with linear search, cell search, hash search, semantic search, and the syntactic search, they are all searching methods with a different logic. The same way, the researchers, they are creating new search algorithms by using some variables, parameters, constraints, advanced novel technique, like that. So whatever technique you are proposing or you are inventing, you have to justify your method is efficient one by comparing the your method with available existing methods proposed by other researchers based on the space and time complexity. So say here they taken 2 binary search methods that time complexities are more, and they are taking 3 blue color advanced binary search methods. They are taking with respect to the number of inputs 1024 maximum inputs, their graph efficiency like that. But when you take the linear search with the different variables and constraints up to the input of 250, they are giving the good result. Their space and time complexity is very less compared to the binary as well as advanced binary techniques. When the input size increases beyond 256, their efficiency decreases. So like that, you have to evaluate. So any doubt in this particular slide? Any point, any idea you got from this? What is the latency? Have you come across the word latency? Abhishek, what is latency? I think you studied operating system last semester.
Huh?
What is the word latency means? Anyone?
When latency basically
What
doesn't
is
difference between
latency?
the basic difference, like the time difference we get between the input and the output.
Yes, or we can say it is the time delay. When you are giving the input, when you are getting the output, throughput, latency, time delay is called latency. So almost we covered almost all the topics in unit 1. One more topic, ADT, ADT topic is pending, abstract data types, that we will discuss in the next class. So We have discussed already algorithm, introduction to algorithm, algorithm design, complexity, asymptotic notations, data structures, types of data structures, classification of data structures. Only abstract data type is pending that we will discuss. For your understanding purpose, we already discussed what is linear search and binary search. So I taken this particular comparison so that you can compare two different algorithms, especially in searching, linear search, binary search. What are all the other searching techniques mentioned in your syllabus? Any idea? Have you gone through? So if you understood the difference between these two searching methods, you can easily search means searching, and if you are using linear search concept, what is the logic? Binary search, what is the logic? So today or tomorrow, I will upload this PPT. I need to update. Anyhow, all those topics are already in the syllabus textbook. Textbook, it's there. So if you take the differences between linear search and binary search based on the time and space complexity, they given what is the definition, what is the space and time complexity, and how the implementation is done, what are the algorithmic steps, start from the first element, compare the current element with the largest element, and what is the pseudocode, and what is the main difference between both. So in linear search, an algorithm to find an element in the list by sequentially checking the elements in the list until the matching element is found. Also called a sequential search. Linear search is also called sequential search. The time complexity is order of n for given n numbers. In best case, it is to find the element in the first position itself. It is not required to sort the array before searching for the element. We can search for the element in unsorted array also, and it is anyhow less efficient and less complex also. But if you take binary search, an algorithm that finds the position of the target value within the sorted array, also called off interval search and the logarithmic search. So the alternative names for binary search is called off interval because we are finding the mid element, pivot element, or logarithmic search. And time complexity is order of log to n. Best case, it is find in the middle position. So that is the first position, comparing position. It is necessary to sort the array before searching for the element. So if you are using a sorted array, the complexity will be reduced. It is more efficient and more complex also. So we taken the binary definition, time and space complexity, algorithmic steps, pseudocode. And in binary search, how we are finding means we are taking the search element is 23. We are finding the first element L equal to 0, last element lower boundary, upper boundary. Middle element is 4th because 9 elements are there. We are taking the mid as 4. The search element is compared with the 4th element. It is not matching. So anyhow, the list is already sorted. The searching element is 23. Definitely the 23 will be in the upper bound. So we will take the upper bound. Again, we will discard the lower bound. We will find the mid element. Again, mid element is 7th element. We will compare with the 7th element. It is not matching, but the element is greater than the searching element. So the searching element will be in this boundary. So we are fixing the lower bound as 5, upper bound as 7. Within this, we are finding the mid element. Now the mid element is 23. The search element and the mid element both are matching. So the element is found. So that is the binary search. Given array, midpoint, compare with the midpoint, whether the number is greater or lower. If it is greater, go to the upper bound, again find the midpoint, find out again here in the lower bound, again find the midpoint, compare, now the element is found. So anyhow, I will share, just you go through it, you will get an idea. So whatever topics we discussed today, you just go through it. If you have any doubt, ask me in the next class. So the meeting will end in another 1 minute. So we'll continue the class in the next class. Thank you all.